Hey, welcome back to the Mining Pod. On today's show, we're joined by Core Scientific and Proto. Proto is a subdivision or different entity of Block, Jack Dorsey's bank. It has a lot of Bitcoin focuses. You might remember from last July where there was a press release from Core Scientific talking about them working with Proto and going to put out 15 exahash of new Bitcoin ASICs based on Proto's new chip design. Well, we got them here first. Nice little exclusive on the Mining Pod. Thank you to Proto and Core Scientific for making it possible. In this show, we talk about Core Scientific's ambitions with this miner, how Proto is designing the chips and the system entirely for different mining specific implementations, and also just like where this project is going to go over the next few years, who they want to work with, why they want to work on this project, what's the ambitions for the Proto side. Thank you again to both of them for making this possible. And thank you to Lee Bratcher and the Texas Blockchain Council for also making this show possible. Be sure to go check out the North American Blockchain Summit videos on YouTube. Okay, first a word from our sponsors, and then we'll jump right into the show.
Are you a retail or institutional investor interested in Bitcoin mining companies? The Miner Mag brings you free data and analysis from all major NASDAQ-listed Bitcoin mining operations to know who stands out. Check out visualized metrics and data-dependent stories at theminermag.com. Thanks for listening to the Mining Pod. Want more? Subscribe to our main feed on Apple, Spotify, YouTube, or wherever else you get your podcasts for another weekly show on Bitcoin stocks. And check out our newsletter at miningpod.blockspace.media today.
Welcome back to the Mining Pod. We are doing a live show. We're in Dallas, not in Austin. I feel like I'm normally in Austin for live shows. But we got three gentlemen to talk about the new Proto miner. Welcome to the show. We'll do quick intros and then dig into the new unit you guys have been working on together for a little bit. Perry?
So I'm with Block, or Proto, Solutions Architect. Work with the product team, the business team, and the hardware team. Used to be the CTO at Argo.
And long-time listener.
And yes, long-time listener, absolutely.
Upset I had that accolade there.
And also Ken, I'm the Chief Development Officer at Core Scientific, been with Core from the beginning. I work mostly in strategy and revenue for Core.
Larry Com, I'm the Chief Technology Officer for Core Scientific. We're prepared for a very long time, and I developed the hardware solutions as well as the scalable infrastructure.
You guys have worked together before?
Yeah, for a long, long time.
I didn't know that.
2018, 2019, around there.
Okay. What were you guys working on before?
So Perry had probably one of the largest fleets in the U.S. Of mining equipment, and I was helpful.
No, it was good. We were hosting with Core before we built our own sites. And I mean, there was a lot of machines. I think it was about 60,000 miners at one point. And it was, the operations, the management, the software. It was weekly calls with Larry, his team, managing everything, learning. Like, we wouldn't have been able to build what we built later on if we had not worked with Core early in and learned what we learned. So, yeah, definitely. Seems like it's been like a lifetime, but it was like 4 years.
And that was at Argo.
Yeah,
I've heard it.
Yeah.
Okay, cool. And you guys built hardware at Argo.
We did. So we were one of the four partners of Intel at the time. And then we basically worked with another team to build the block miner. That's what it was called. With their block scale ASICs. And that was kind of our first foray into custom hardware at the time and designing something, that was slightly different than the Bitmain stuff.
Yeah. Okay, so now fast forward to 2024, we're here. You guys have put out the announcement. I think there's been a few announcements about like you guys are going to build an open source ASIC. Jack Dorsey's obviously on the more ideological side about these things with like his personal investments in Ocean, and then like his desire to see like more fiat money building up the Bitcoin ecosystem, and mining is a part of that. And so you guys have like put out this, I think it was a blog post from 2-3 years ago talking about building an open source ASIC, and now we're getting pretty close to it coming out. And that's what seems to be like the idea here.
So I guess what we want to do is basically enable people, instead of saying, here's a miner, here's one shape of miner, and this is what you get, and build around it, is people have different needs. People have different electricity prices. People have different climates. And so not everyone's an industrial miner. Mining started with people mining at their house with CPUs. So at the heart of each system is an ASIC.
Yeah.
So if we say, we're going to build a system, and this will be for, let's say, a majority of people who will want to mine, but Core Scientific needs might be vastly different. Instead of like they build great infrastructure, But instead of them having to build infrastructure around, let's say, a shoebox, it was, what would work for them. And that would integrate with their data center with the other things we're doing. And so this is one of those like first applications of, here's a building block, see what you can go do. And how can we help? So that was kind of what our vision is. I think this is one of the, definitely won't be the last, one of the first that's coming out. But I think there will be a lot of other people that will build some pretty cool things. The thing is, we can't think of everything that needs to be built.
Yeah.
And so by giving people the tools, let's see what they build and how we can help along the way.
Okay. And so what sort of tools are coming out in the near future for people to build?
So the first thing that we put out was the MDK, the Mining Development Kit, right? And it was, we used Intel chips for those. That was just to show people, okay, here's the board, here's the firmware, and give us feedback. What do you want to see different? What is right? What documentation would you like? How can we improve the API? And, we made it a form factor that you could put in AS19, use an off-the-shelf power supply. Basically, instead of having to buy custom components, there's a lot of these out there. Grab what you need, play with it, tell us. And, that one's aimed more at developers. It's not something that's going to be, mining at scale. It's an older ASIC, but it was kind of learning for us, learning for, developers, customers, getting feedback, and then saying, okay, now here's what we would do when our chip comes out.
Okay.
Yeah.
And the big thing here is the chip, like getting the chip allocation. And that was, to my knowledge, it goes back to the Intel idea in 2021, 22, where they had their second wave of chips came out. A few people bought them, Argo, Grid, Hive, and Block. And I think there might have been a few others, but those are like the bigger purchase orders for Intel's new chip. The only grouping that made anything out of that, to my knowledge, was Hive with their buzz miners, and they deployed a few thousand of those. But you guys kept on, held those chips and then have worked to develop them now, or maybe you guys aren't even using those chips anymore.
So we're basically building different applications with them. Like the MDK was the first.
Yep.
As you know, in mining efficiency is very important. I mean, these chips are now a few generations old.
Yep.
And so we look at it as not something you would use for mass scale mining, but as a tool, as a learning tool. And so, it was an opportunity for us to get them, basically see what we could do, put them in the community. I think we sent a couple thousand to Core as well. And, that's kind of how it started, the back and forth. We said, what would you do if you had these chips? And that's kind of where the discussion got rolling, and then, ended up where we are.
Larry, what would you do if you had those chips? Or what did you do?
What we use the chips for, primarily is for practice. It's for understanding thermals. It's for seeing the right, and the wrong decisions that might be made. In Courageous, for us at scale, we see this equipment in a different way than others. We put it adjacent to many units. We cook them, and we turn the heat up. We see how they perform, and then we make notes. And the notes for us are, critical IP that we've obviously shared with Block, that we create, but also, as creators ourselves, building our own circuit boards, we're trying to find, innovative ways to make, repairable units. We're trying to find ways to create durable units. And of course, the end goal is to develop our own equipment with Block that can be, is put in any one of our particular data center designs, and for us.
Okay. And so maybe to back up the truck a little bit for anyone who's new to mining and might stumble across this podcast. Why would a Bitcoin miner like Core Scientific even want to get in on the scrum of building your own ASIC?
I can dive into that.
There we go.
So if you look at it in the top of this thing, something to do with the shoebox. If you look at the shoebox, it was basically, there was ASIC mining for Bitcoin before it, but when the S9 came out, when Bitmain put out the S9, the same design team, they went on to What's Miner. You see the same shoebox of What's Miner. If you think about what that was designed for, it was designed to mine in China. It was designed to mine in the Mongolian desert and then be lifted and shifted into the jungle when it was rainy season. So they designed a machine for literally grabbing by the cord and throwing on your back and moving across the country every year. Just so happens, it's a very efficient machine. Matter of fact, people were still running them all the way up into 2021 in the bull run. I remember SAI and ScumpCon in 2021 bull run. So they designed a machine that just didn't break. Now, since that time, there's been lots of machines that do break. But Bitmain took and doubled the shoebox, and they kind of kept that design, and they now led the immersion because Bitmain and Whatsminer are the largest, and basically all those designs came back to the same design team. Literally, the same design team did both of them. That's where the industry developed. And in the nascent time, when Core was just getting started, and we were the largest industrial miner outside of China, there wasn't a lot of options, but we mined with a lot of different machines. Larry and his team have data. We've collected data over 800,000 or 900,000 different units from over 20 different manufacturers. And at Core, because we've been doing this a long time, we've also been doing it across a lot of different environments. Perfect environments like Marble, North Carolina, where it's 45 to 85 degrees year round. Environments like West Texas, where it looks like Dune. Environments in North Dakota, where it looks like Hoth, right? And we collect all that data. And then when the block team comes and said, look, we had this chip, we have some ideas around this thing, and we're going to kind of open source, it gave us the idea to sit back and talk to Larry and his team, to talk to our operations team and say, well, if we had to do it based on all the information we know, what would we do? And that's where this conversation came about. It said, okay, so, we don't have an ASICs team. We don't have a team that can design a chip, but we have teams that very much have ideas and skill sets around facilities, thermodynamics, temperature. As Larry just mentioned, his team, we are, the circuit boards themselves, how all those things operate. So this gives us an opportunity. This gives us an opportunity to really design from the chip all the way, the facility itself, all have to make the facility itself a big miner. Because that's the way we operate. Like we have to operate as a profitable miner. So that means our software, and Larry, his team's part of that, the main part of that, our software and our operations team, we turn machines on and off all the time based on temperature, based on hash price, based on volatile input price of power.
Yeah.
And having a chip and having our own designs allow us just all kinds of flexibility. And at Core, we really think going forward as a mining opportunity, there's been different times when your overall goal was just to get machines up as fast as you can and get them and running as much as you can. But the tighter and the tighter hash price gets, and the more efficient machines get, the closer they get in that efficiency scale, the bigger the overall network's going to get. It means you're going to have to really play in that volatile game of watching hash price, watching electrical inputs, because everyone around you is very happy. Bitcoin, as we said today, is sitting almost at all-time high.
I think it broke all-time high again this morning, right?
Yeah, all-time high today. Well, that's awesome. If you're a Bitcoiner, that's great. But if you're a miner, hash price is really what matters.
Yeah.
So if the network is enormous and your power prices are high and your hash price doesn't move, it's really not that much different. We're not even back to hash price what it was in the beginning of this year yet.
Oh,
so
yeah.
Think about that. I mean, as high as Bitcoin is right now, we're still not back to hash price from March.
Yeah.
I think we got, at this point where the network's at, we got to get to 120 to even get back to March's hash price. And as a miner, you think about hash price. And that's where the flexibility of having a great team that's designed chips on our team to come in and say, here's the kind of boards we want to do. Here's the kind of design we want to do. And it might be a shoebox, but it might also be a inline URAC.
Yeah.
It just gives us a lot of flexibility. We think that flexibility allows us to be profitable in a very volatile Bitcoin mining environment.
I want to go back to the engineering and talk about the form factor in a little bit, but Harry, I want to go over to you and talk about the reason for putting investment into this with Block and what the competition landscape looks like. And maybe the place to start with that question is like, do you guys even care what the competition looks like? So if you're trying to open source a lot of what you're going to do at the end of the day, not necessarily everything, but a lot of this, do you even care about the competition as much?
Yeah, I mean, look, we have to see what everyone else is doing, right? At the end of the day, this is a business venture like anything else. Ideally, it has to be profitable. But, we open source everything that we can. There's stuff in our control that we can't. But the big one is, the firmware.
Yeah.
Right. So people can see there's no back doors. If there's anything they want to do, any changes they want to make. But I think, again, the reason was it's good. Like there's other North American competitors coming to the market now, which is great. But like Block has made over 30 million plus consumer devices. So we've got a pretty good history of making really reliable hardware. Our ASIC team is not something that we just put together overnight. They were building the ASICs in all our payment terminals.
Yeah.
And so, we understand uptime, reliability. Like look at Square. If a payment network goes down or that reader doesn't work, people don't get paid.
Yep.
Money doesn't go to their banks, mortgages don't get paid. So it's the severity of it, we completely understand. And we said, when we started looking into this and we kind of saw, reliability issues or, how things were being done. We said, could we do this better? And, talking to Core, one of the things that we learned is, miners just don't run in a vacuum. There's infrastructure cost.
Yeah.
And as hash price gets tighter and as those margins get smaller, well, there's people always talk about dollars per terahash per miner, but what about your cost per megawatt, right? That's the other part of it that always comes up. 400,000 per megawatt to build that air, or 300,000 or 500. Well, if you look at it, instead of, I have to build this facility over here for this miner over here, like Russell said, it's in, a single miner, a single huge miner, let's say. How do you drive that cost down? And so this isn't something that we knew when we started, but talking to these guys, understanding it, we said, oh, this is where we may not have the expertise on that side, but giving them the tools to do it can make them, more efficient with everything they've learned over those 800,000 plus miners that they've had. Yeah. So that's kind of the genesis of it and how we kind of ended up here.
Okay. Well, I want to keep going on that for a second more. The other investments that Block has made, that you guys have the new BitKey that's coming out. You guys obviously have the Cash App integration. A lot of people are purchasing Bitcoin on Cash App. Then Block itself, I believe, just has like investments in these sort of things as well. And then Jack obviously invests in tons of different Bitcoin projects. Tell me a little bit about like the desire to build a different system for Bitcoin itself. Like what's the ideological reason? And then is there anything to do with like needing an ASIC developer in the Western hemisphere? Like I've heard that pitch a lot. Is there any relationship between those things?
So, there's a couple of different points you brought up there. So let's say BitKey, right? Yeah. One of the features that we just rolled out is the inheritance feature. The amount of times that, I would do mining and, using competitors' wallets and trying to explain to my wife, this is a seed phrase. Should anything happen, this is how, and she's looking at me like, what are you talking about? Mm-hmm. It has to if we want to get more people involved, it has to be easy.
Yep.
And if you've ever used any Square hardware software, the one thing we do really well is make it, simple, make it easily to understand. Yeah. So if we want Bitcoin adoption to grow past just, the tech geeks like Larry and I and Russell, we have to make it where the average person can pick it up, understand it, and just like any other app, And so if something happens, give them a level of security that they are comfortable with, and those who want more, make sure they have the ability to do that. But instead of saying, this is the way to do it, this is the most secure, a lot of people are just going to say, I don't want to. The amount of people will say, well, what if I want to reset my password? Yeah. Who do I call? Yeah. That's not how it works. But so there's always trade-offs between security, convenience, and adoption. And I think one of the reasons we want to do this is find that middle line, but also let people kind of go with what they're comfortable with.
Okay.
Yeah.
And I'll ask my second question there again, because I kind of mushed them all together. I've heard from a few pitches on this miner, and there's certainly on the Ardine stuff, which is a competitor to you guys, that there needs to be an ASIC built in the Western Hemisphere, that we need to move away from East Asia and building there. Any thoughts on that pitch to from Bitcoin miners?
It's how much value will people put on something built, stateside?
Yep.
Whether that's, I know people always say America. As a Canadian, I say North America. But there's always all sorts of, tariffs happening, trade wars, other uncertainty over chips. And now there's foundries coming to Arizona. And so anytime you can diversify supply chain, it's not a bad thing. Look, the majority of mining is now happening in the US. There should be some manufacturing here as well. And it just makes sense. We shouldn't be reliant on, other places where we don't know if we can always get the supply or, stop. So why we have the talent, we have the engineering, we'll have the fab soon. So why not have it homegrown?
Today's show is brought to you by Digital Shovel. Digital Shovel is a leading manufacturer of modular mining pods as well as PDUs and switchgears. Unlike many other competitors, their product is designed and manufactured in North America with a complete UL inspection on the entire unit, not just individual components. Additionally, Digital Shovel is one of the most vertically integrated manufacturers of over 75,000 square feet of sheet metal shop, SMT and wave solder PCB assembly, as well as final assembly all under one roof in Toronto, Canada. Their price point leads the industry when compared to products with rates as low as $69,000 per megawatt for a complete data center with smart PDUs and switchgears. To learn more, visit digitalshovel.com.
Does it matter to you guys at Core where ASICs are coming in from?
it is definitely top of mind, I should say. So, I'll say, I told you we run between 800 and 900,000 miners. The vast majority of those are Bitmain. And the current generation of Bitmain miners are great. They really are. They've had problems in the past, like the 17 still gives people PTSD, but very you. But there is a issue there, a geopolitical issue there on the supply chain side of things. If tariffs become an issue, as they did before, reminding, it rocks our world. The last time we had the tariff issue, it really rocked our world. Now, those Southeast Asian miners worked very hard to move their production out, or move their assembly outside of China. The chips, of course, are TSMC, but they worked very hard to do that, to address some of those issues. But it's still what we talk about the fact that, right now you've got your large Southeast Asian guys, Bitmain, WhatsMiner, you've got Auradine, you've got Block, primarily United States, and MENA in the Middle East, you've got Chain Reaction. It's actually great to have some ASIC teams that aren't sanctioned in Southeast Asia. I think it's actually good for Bitmain, or good for Bitcoin as a network to have a global footprint of mining, but also think it's good for Bitcoin as a network to have a global footprint of ASIC manufacturers. Because the Bitcoin network is so tied to your ASIC manufacturers right now. So I think the diversity is good. Yeah. So certainly it leads to better engineering, because when there's no competition, engineering, the machines are not as high quality and the efficiency is not as good. When you have competition and there's not a one-trick pony, that means that people are going to be constantly iterating to put out a better compute device.
Yeah, definitely. Go ahead.
We also saw, like, when the tariffs came and the machines moved from China to other countries for manufacturing. I mean, a lot of people would ask, is this the Malaysian one or is this the Chinese one? Because we saw a difference in reliability.
Yeah,
right.
Different facilities.
And because it was done so quick, it was so fast to get around the tariffs. But so if we already have those things set up, we don't have to sit there and wonder the same machine, where was it manufactured, because there's a difference in quality depending on where it's coming from. Like, that's not something that you should ever have to worry about.
Yeah. From my back knowledge on this, there was 5 different assembly facilities across East Asia. And then every single one had like different code on the back of the machine. And then people would try to purchase ones based on like knowing which facility would be a little bit better. So yeah, it gets pretty in depth.
Larry and his team have very specific opinions on all those things.
Yeah, Larry, actually, can you tell us a little about that? Like, what have you guys seen in the last few years that you've been frustrated with, or you'd like to see different in a future iteration of miners? Maybe put in the positive light.
I mean, I'd say that the quality's gone up. And
Okay.
nothing happens in a straight line.
Yeah.
It's got exceedingly better over the last 3 or 4 years. We think about things in terms of repairability. Some of the defects are they're really paying a lot of attention to the flaws that they've might have introduced. And we pay attention very closely to sort of which models we prefer for long term. We did also design our own repair techniques. We don't necessarily do the same as everyone else. How we deal with certain characteristics of the device, is unique by model, but also unique by like location where we operate them. We could have the same unit running in one place versus another where performance dramatically different.
Yeah.
I'd give a thumbs up to sort of the improvement in quality. And from that, where our devices are also that we're developing, they're improving in quality.
Yeah.
We're learning a lot from the lessons of all the miners that are operating these, and seeing the diversity in models that came out of Bitmain during that time period. Certainly we never got lucky and got a lot of really good ones. But because we're also the hoster, because we brought in so many clients, we've seen everything. And we have to help them, get the most out of it to ROI their units. What we've developed in terms of like custom firmware, we've seen that different devices also interact differently with the firmware. And so we have to build a very diverse set of routines. And that's a bit challenging. Our custom firmware, has to identify all of these different variants and perform differently depending on whether it's got 2 or 4 sensors for temperature, or whether or not it's got voltage, MOSFET gate. So we think about all that, but I'm impressed the technology has really improved, and the work that we do is building on top of that.
You made a point I want to highlight.
Yeah.
It goes back to why we're working with Block on developing our own, or developing the miner itself. It's the repairability piece. So, having been doing this now, industrial scale mining, I think we mined our first Bitcoin in January of 18 at our Marla facility. We've had to repair a lot of machines.
Yeah, there's a few, right?
Yeah. And we do all our repairs. We have repair teams at every one of our facilities. We also use some great outside repair guys whenever we get overwhelmed. But I go back to this. We have a lot of data on what needs to be repaired, what causes repairs, where the problems are.
Yeah.
And a ton of that leads directly to our thoughts on what we want in a miner. And we've given all that feedback to Block and Perry and his team, because let's just take, for instance, fans. They break all the time. Well, if the fan costs 90 cents and it breaks 80% of the time, or you can spend $6 and have a fan that never breaks. Now, if you have to sell 1 million of these machines around the world, you're going to go with a 90-cent fan because you're a manufacturer, and that's what you do. But for us, who has to operate those things, that's one area where we would spend the extra few bucks on per machine basis, right?
Yeah.
And Larry could go into all kinds of things, but one of the things his team does is we analyze where this repair vectors are coming from, and then we use that data in what we think is are good designs. It's like, okay, what's causing this repair? What does that piece cost? Can we improve that piece or take that piece out altogether? Right? Yeah. If it's a temperature gauge that causes something to go down and it's not really useful, all right, well, let's just get rid of that damn temperature gauge. And I'm not using the right information here, but I'm trying to make it. The repairability that data we've collected over the year feeds directly into some of the stuff that we're working with Block and those guys on, as far as what we think the device itself should look like or how it should operate, to try to take that downtime from repairs off the table.
Yeah, I know. If we want to reduce the number of trips to the shelf, we want to reduce the time spent at the shelf, dealing with these units. We certainly want to reduce the need to bring them back to one of our repair centers at one of our sites. If it can happen at the rack, we want to tap quickly. We want diagnosis to be quick. And it's all about uptime and utilization. Are we getting the most out of our equipment? Is the most amount of equipment on lot?
And just to add to that, like, reliability is one, and the other second part is upgradability. It always seemed kind of crazy to me. Anyone who's played, PC games, upgrades their GPUs. Yeah, I don't think they've ever thrown away their motherboard and their power supply when they want to upgrade their GPU.
Yeah.
But that's what we do with miners. Yeah. Right. We upgrade the whole unit. And so when Russell's saying, like, instead of a 90-cent fan, look at a $6 fan. Well, if you're replacing that fan every time, it doesn't make sense. But if you're not replacing the fan, you're not replacing the PSU, you can have a better PSU, you can have a better fan. And from a reliability standpoint and upgradability, you can design a machine where you're just replacing hash boards, let's say.
Yeah.
Right. So when you control the ASIC, when you build the ASIC, you can, make it where it's compatible between generations. And so this is kind of the long-term vision where, like, it reduces a lot of e-waste, a lot of money saved on shipping, but and I'll let Larry and Russell expand on this, but I know they have facilities where you have different power prices.
Yeah.
And as new miners come in, you move miners around, but it's easier to move boards around, right? If uptime is what's really the most important thing in utilization, it's a lot easier to take a board out, depending on, you can take it out from the front, minimize it on the rack, like Larry was saying, as opposed to taking a machine, putting it in a box, packing it up, shipping it. There's a lot of cost there that isn't always measured in that dollar per terahash initial buy.
Yeah.
Right. If you look at the metrics of man hours, downtime, then what is the true cost? The total, let's say, lifetime cost of this miner versus something that's designed somewhat different.
And to that point, that's exactly how we optimize our facilities.
Yeah.
A lot of people have, miner management software skill. We think more as workflow management. How best to spend our, person hours, making sure that our facilities are, humming along in, an optimal fashion, that we're dissipating exactly as much heat as we can, generate, that we're bringing in, the right equipment to a facility. And if it's not necessarily the right one, rather than, do dramatic lift and shift, we tune the power profile and create an opportunity to, get the most out of that equipment until logistics, fall into place for it. managing all that time and all that personnel, that's what makes us a big business. But as engineers, we've had to create all those tools, and all of that information and all that learning that's going into the designs that we work on together.
I have some speculations now on what this is going to look like based on what you guys are saying, but what is the ideal form factor for Core Scientific look like? Is it like the new UH21 machine with Bitmain that Hut 8 is putting out, where it's kind of like a server rack model, or what is the best form factor for a team like you guys?
That's a loaded question.
Well, a lot of build designs. Yeah. One of them is great for something.
Yeah. For
our ability to dissipate heat takes center stage, but the ideal form factor is something that's flexible.
Okay.
Something that can meet our needs in various ways. Barry mentioned upgradability. Our ability to balance the power.
Yeah.
That also comes with the designs that Barry's talking about. We look for flexibility, and we also look for the ability to reshape it. So we do one manufacturing run, and we like what we do. We might do it a little bit differently the next time.
Yeah,
and we want those to be compatible. We're forward thinking in terms of everything that we produce together. We'll always have a spot because in the Bitcoin industry, we all had to adapt how it's come in, so we can certainly make anything work. However, we've come up with some really great building designs, and now we have great mining designs to go with it.
So I'll give you for example, let's just say we're on a bull run. Let's just say Bitcoin keeps going, hash price is up, which means you want every machine you can running as much as you can. Right now, if there's a repair situation, technician has to go out, and if it's a hash board that needs to be repaired, the whole machine has to come down. Hey, I'll lose 3 hash boards. Why do I have to do that? And Perry and I have had this conversation. Why can it not be I turn that machine off, I open the back, I pull out the bad hash board, I slide in the other one, and the rest of that machine keeps going, and then just the hash board goes back to the repair room.
Yeah.
I also want to make another point we talked about, and that is, and Perry talked about this a little bit. We actually at Core, one of our key indicators is we mine for a profit. That's an interesting thing among miners.
Yeah, you guys are different. You guys are different for that.
But we actually think it's important to be a profitable miner, right? So I'm not putting dig on anybody. I'm just saying, we
didn't name anybody.
We mine at a profit. So in order to do that, though, we actually have to look at our facilities and our PPAs, our power contracts. So you'll see at Core, we have an amazing operations team, and we do what's called Tetris that coincides with, and it doesn't happen all the time, but when power prices change, our PPAs change, or hash price makes big moves, because what we're going to do is we're going to operate at our lowest fixed price power. We're going to operate our most efficient hash boards, our most efficient machines. And right now we have to move old machines, but it'd be so great if you would just say, as Perry said, hey, how much easier is it just to move a couple hash boards as opposed to a whole device? But in a very volatile market, our West Texas market, where power prices go negative sometimes, or can go very, very high, we actually operate our least efficient machines there. That's because if I have a machine that's super efficient, I want it running all the time in a bull run. Yep. And I have my less efficient machines running over here in this very volatile market because they're less efficient. But if power goes down negative or it's very, very cheap, even those less efficient machines are profitable miners there. And right now, we do. We load up machines and we move machines around. And it doesn't happen all the time. Otherwise, our hash rate wouldn't be as stable as this. But we do that in order to be an efficient miner. And that's some of these stuff, along with facility cost and facility design, that's leading us to say, okay, what are some things we would do if we had a chip and we had the ability to design a unit around the way we operate?
Yeah.
And I should say, we're not designing units for anybody else. What we're talking about is taking their chips and putting it the way we operate, because the way we operate is the way we operate.
Yeah.
We're going to do it efficiently. It's not going to be the same for everybody. For instance, we're very comfortable in air-cooled. Yep. Some people are very comfortable in immersion. We're just very comfortable with air-cooled. We know how to do that, right? Yeah. So I'm not saying we'll never do immersion, but right now at all of our facilities, air-cooled just works fine for us.
Yep.
But having that ability to have that flexibility is huge, and we think it's going to be valuable going into the future with the volatility that's going to be happening around hash price and BTC.
Even the design that may work for them in their current infrastructure may not be the design that they choose, not to speak on their behalf, but in their new infrastructure.
Yeah.
They might, if your new building, let's say, has traditional, URACs that you're doing a lot of AI. I hear they dabble in that. So you may, sometimes it goes, you've got your PPAs, You've got a certain amount of power you have to use. Sometimes it's a memory intensive task, not power. So how do you maintain that power? Make sure you're using it. You can add mining. Now, does that form factor the same as a traditional industrial mine? Maybe it is, maybe it isn't.
Yeah.
But they have the flexibility now to see, what fits here, what fits there. And that's kind of what we want to do. If we can make mining as, you asked why we started this, what we want to do, make it as prevalent and as easy as possible, not just for the people at home, but also people like Core.
With past manufacturing partners that we work with this type of collaboration is difficult to achieve.
Yeah.
Especially with different time zones, being into different sides of the world. What we have here, building units in North America is fast iteration, learn very quickly what works. And it's really mutually beneficial. Everything we discover or that they discover, is turning into something that previously was just isolated.
So I've actually had this question for a little bit, and I'm glad I got you guys to answer it for me. Some experts, kind of nice. When we're looking at the cross-section or the intersection, I should say, of AI infra, HPC infrastructure, and then Bitcoin mining, it feels like there's a lot of people trying to make the two work together. And I can think of at least 2 miners who have put out products and they're saying this can work for mining and AI. It's can it really? So I'm wondering from your guys' perspective, and from Block's perspective, how do you guys make those components work together? Compare, you just mentioned that a second ago, there is going to be some infrastructure which people are going to want it to work for both because they have it set up that way. But on a fundamental level, they're doing different tasks. So how does that matter for this? Or are they so similar that you can make it work?
I think the similarities basically, and again, I'm going to let them expand because this is their area of expertise, not mine. But, you need power. You need network connectivity. And then it's the redundancy is, I think, the big difference, right? The beauty of Bitcoin mining is you can put it in West Texas where, the power prices spike or you've got one fiber line coming in, something happens, it gets cut, or you've got, a Starlink backup, let's say. That's enough bandwidth. You can keep going. AI, personally, I don't think it'll work, but I'll let Larry and Russell speak to that. But you can always find stranded power and you can put Bitcoin miners in, right? If you have electrons, you need transmission lines. If you have gas, you need pipelines. The beauty of Bitcoin mining is you can literally take those that are stranded and send it wirelessly through data.
Yeah.
But the power infrastructure up until the facility is relatively similar. I think that's where they kind of end. And what happens inside that facility, how it's designed, is vastly different.
Okay.
I think what we do at Core Scientific, and a lot of us, the majority of this Core Scientific, we were doing high performance compute, and then we got into Bitcoin mining. We built really robust tools to solve really complicated problems. But the tooling that we built, the circuit boards that we build with the Block, those are not our first foray into it. We've got an embedded engineering team at Core Scientific. We build pressure sensors, we build power monitors. We do inline power monitoring. That's how we ensure that we're achieving maximum efficiency with miners, but it's also how we monitor explorers. We're looking for indicators that the equipment might need service. All of that infra that we've built, we've got a lot of cool things we're always working on, cool circuit boards. But as we build out those components, we've made mining more efficient for ourselves and profitable. But we've also built, portfolio of amazing data center technology. And, sometimes they're like, we could just sell that. And it's or, what we could do is we could build a ton of it and deploy it at scale, and create, a scalable business for high performance compute. And I love GPUs.
Yeah.
I had 30 in my apartment at one point, and I know it was before they were expensive.
Yeah.
And then I like also giving away GPUs. It was nice to have all that equipment, after I got my useful time out of it. But going deeper into the stack, we found that we can do a lot of those jobs that you'd see at a very large data center. We can do it in more efficient ways. Yep. And the two are compatible. You may not put miners and GPUs in the same facility, although we have, in the past, especially for our client requests. But The similarities are there in the infra. There are, dramatic differences with dealing with HPC. And what is required for an M plus S1 and for scaling a very large facility. It's as shocking as it is to go into one of our large mining centers, it's even more shocking to go into one of our HPC centers.
Yeah. So to address the question you asked, do you mine and do AI in the same facility? The answer is not really.
Yeah.
Okay. So, we just released this morning our Dent facility, which in my mind, again, I'm biased, is probably one of the most sophisticated air-cooled mining sites on the planet. This announcement we're converting into HPC, AI specifically. There's billions of dollars going to go into that, converting that facility. Now, at that facility, we're actually using all the same buildings. So if you've been to that site, those buildings that are there that are currently mining are going to actually house the GPUs themselves. However, outside of the medium voltage switchgear to the substation and the building itself, everything else is going to have to change. So a couple things that are important to think about when you think about Bitcoin mining versus AI, and Harry touched on this a little bit. Bitcoin mining is super flexible for the power grid.
Yeah.
AI is not. Now, they both actually bring benefits to the grid. For Bitcoin mining, it's that flexible load. But as a Bitcoin miner, I need incredibly cheap power. And to take that cheap power, also have an incredible amount of flexibility. I don't have that flexibility when I'm running a large language model or when I'm running inference and that kind of stuff.
Yep.
You can, but the market's not there yet. All right. And what I mean by that is, one of the things we announced, I don't know, in the press release, but one of the things, the piece that was important on the Dent piece was moving that very large PPA, zoom to 400 megawatts, from a flexible load to a firm load. And so that nearly 400 megawatts is going to end up being a little over 260 megawatts of critical IT load at Dent. So it would be 400 it's nearly 400 megawatts. I had to be 400 megawatts of Bitcoin mining, but it's not. It's going to be 260 something of critical IT load. That's because, Bitcoin mining has almost zero PUE.
Yeah.
But in the world of GPUs, there's a lot that goes into cooling, a lot of redundancies and batteries and all that. But that load is very different for the power grid. And when you were dealing with ERCOT and you're dealing with that large GPU load, you can't have the frequency harmonics going back to the grid can brown out a town. So it's just so different. I can't imagine trying to operate, or why you would operate Bitcoin mining at a site where you have to have the contract be a firm load contract.
Yeah.
Because it's going to be too expensive, right? I just can't imagine, because it's more efficient to mine Bitcoin at a site where you have volatile power pricing and you can't have very low power pricing. Whereas in the world of AI and HPC, you want to have that firm price, that firm load contract, but you're willing to pay more for it. And that's the benefit that AI can bring to a grid. So AI, your utility companies can make above average margins on power. And those above average margins in a regulated environment actually means you're putting money back into the grid. So it gives them money to upgrade transmission, upgrade substations, upgrade generation. Now, Bitcoin mining is the other side of that. If you've already have that infrastructure in place, then Bitcoin miners can take that excess energy that you're producing, instead of you dissipating into the ground, they can buy that from you. Yeah, a very, very low margin, but the contribution margin is high. So even though you can do AI and Bitcoin mining at the same site,
Yeah.
I don't know why you would.
Yeah. It tells from the power perspective, the AI part is like your stable base load.
Yeah.
Right. And Bitcoin mining is your peaker that you can use up and down. You wouldn't use one energy source to do the other.
Yeah.
Right. So that's how, if you look at the grid, they talk about the inverse duck curve, and you have your stable load. Like, you're not going to use, nat gas is usually the stable base load as, let's say, what you would use, a battery for, or diesel gen set, when prices spike. And it's almost like the inverse of that from AI power usage in Bitcoin mining. So they each have a place. It's just how it fits in the grid.
Yeah. Now, you could end up having them, I don't want to say you can do them on the same site, but you're going to want to have two different PPAs, because you're going to have, in your Bitcoin mining, as you said, you're going to have that flexible load for the grid. Whereas your AI, you're going to have that firm load from the grid. So you could actually have, if you had a 1,000-acre campus and you had 1,000 megawatts, you could say this 400 megawatts is going to be Bitcoin mining, this 600 megawatts, but you're going to have two different PPAs. You're going to have two different meters, because your relationship to the grid there is different in both those situations. And if you're paying, 6 or 7 cents for a firm load over here, I don't know why you would mine with it. That doesn't make any sense to me, because you could take that flexibility, that BTC load, you could take it off that site, and it could go anywhere on the planet.
Yeah, right here, literally anywhere.
Yeah.
In the competitive world of Bitcoin mining, one name stands out: CleanSpark, America's Bitcoin miner. At CleanSpark, efficiency isn't just a goal, it's our standard. Our sophisticated facilities are built and led by expert teams who care about Bitcoin and the communities we work in. Scale? We've mastered it. Our large-scale operations have set us apart in the industry as examples of community-oriented building. Our track record speaks for itself. We navigate the complexities of the new economy with precision and with skill, continuously achieving operational milestones. Curious about how we do it? We invite you to discover the story behind CleanSpark's success at cleanspark.com.
In terms of the infrastructure within the Bitcoin mine itself, what are some similarities and differences? Because again, we do keep seeing people come to market saying we have a new solution that works for AI and Bitcoin. And to me, it just doesn't make any sense. And it doesn't seem like a lot of miners agree with those press releases. So I want to hear from you guys, like, what are some things that do make it, like, this is the server rack model that seems to become more popular, like MicroBT is going in all of that. Bitmain has a new unit. Like, there's some similarities there. Direct cooling 2 chip seems to be like a new thing that people seem to like. But maybe just in layman's terms, Larry, like, what are some, can we dispel this myth? Or is there at least some similarities where people can kind of bring something to market?
I think it can look the same.
Yeah.
Certainly you can make a server rack that does Bitcoin that looks like an HPC rack. In terms of power density, and the redundancy necessary to operate it, the investment on the HPC side is so much more significant. We're looking to commoditize the Bitcoin mining side and to be very flexible, hold the board, put the board back in. On the HPC side, we need more reliable equipment, and the quality level is certainly going to be much higher for HPC.
For HPC right now, for AI, our build cost is anywhere from $8.5 to $12 million a megawatt, depending on all kinds of situations. If we're building a state-of-the-art BTC site, I'm $500,000 a megawatt. Why would you spend $10 million a megawatt to mine? Yeah, it's like building an F1 car to go to the grocery store, right? Now, it's kind of fun. Yeah. Look, it's fun to go to the grocery store in it, but why not do it? Yeah. Now, there are situations. So I'm just going to give you one of the outliers where someone may argue with. And that is a situation where you say, and it'd be very rare because I don't know why you would enter this kind of PPA, but if you've entered into a take-or-pay PPA contract, and I don't know why you would do that. We would not do that. If you've entered into a take-or-pay contract, so you had a take-or-pay where you were buying 400 megawatts from Duke Power, no matter what, and then you had a load like this over here in your GPUs, I could definitely see where you would take, and whenever that DPUs are down, you have some Bitcoin miners over here that mine, basically mine for free. But I don't know why you would have a take-or-pay PPA contract. Why would you do that? No, I don't know why you would have a PPA contract where you have very large demand cost anyways. Like, that's something that, and again, us doing this for so long, that's something you negotiate away. You have those very large demand loads. You only want to pay for the power that you use. And some of that comes with paying for your own infrastructure, paying for your own substation, paying for your transmission lines, that kind of stuff. But, unless you had a situation like that where the economics went that direction, and I don't know why you would, because there are more efficient ways to do that, I don't see you, and as Larry said, you can definitely take and make a beautiful liner like MicroBT has done, like a Bitmain has done, that fits in that HPC space. But why would you pay for that redundancy from Bitcoin mining when you can very simply just turn it off? Like, it doesn't make any sense. I would rather take that extra $9.5 million and buy more Bitcoin mining with it and then pay for the extra infrastructure. We're literally working with these guys to lower the cost of infrastructure, right? I mean, that's what we're trying to do, is trying to make Bitcoin mining more efficient, not less efficient.
Yeah. And for us, the name of the game is application-specific data sets. We find the right power, we find the right property, we design the right building, and the right workload goes to that location. And a lot of our sites were just terrific, for a lot of different uses, and we're constantly optimizing our portfolio in that fashion. And the investment that we put in on the Bitcoin side is different. We are investing well. We're making sure the equipment is taken care of. But as Russell mentioned, airflow is our preferred methodology right now for that. And that just wouldn't exist, in a facility where we've had chillers and water towers and, gensets.
Yeah. Okay.
Another example, like we just made a decision to just so happened to be this week. So not only did the Denton, we announced it today that, the Denton site is transforming. We have a site in Muskogee, Oklahoma, just a few hours north of Dallas, where we're sitting right now. And we just did the groundbreaking on that site. Now we started working on that site in 2018 as a Bitcoin mining site, right? We built a 600 megawatt substation there. We worked with the power company to put in 1,000 megawatt ring bus there. And we did that as a Bitcoin mining site. We are now breaking ground, though, as an HPC site. The ring bus will be the same. The substation will be the same. We actually have all the transformers and the switchgear.
Yeah.
Because all those will be the same because they're the same. But after that any voltage distribution that goes to the electrical switchgear, everything else is different.
That helps dispel, I think, some of the interesting marketing language we've seen around products specifically marketed to AI companies that's coming from the Bitcoin mining landscape. So it's been like a little odd to me. I want to finish up with a few thoughts about, get some comments from you guys from the summer press release. So 15 exahash was the goal to build with Block. And then it was a 3 nanometer chip from an unnamed foundry. Are you guys on the record what foundry was at this point, or is it still unnamed?
I believe it's still unnamed. I think it's pretty easy to decipher. But yes, for now, still technically unnamed.
Okay, cool. Well, if you read the Mining Pod newsletter, then you probably know who it is. So subscribe to that. 15 exahash, still on target for that? Or how did you guys come up with that number as well?
So, and this is, I think we've said this. So the chips these guys are designed to go up and down. Their efficiency are designed to go up and down. So if hash price is running 20 cents, you crank up the joules per terahash goes up, terahash goes up. So the 15 is really more of a middle of the road target.
Okay.
Right. Because what we did announce is we're buying the chips themselves. Right. So we're buying a fixed number of chips over a period of time, designated over amount of period of time. What they're delivering to us is chips that have a range of joules per terahash. And then Larry and his team will, work with Block's team and say, okay, here's a target we want. But, we want to be able to say if hash price goes down to 3 cents, well, it's going to be lower. If hash price goes up to 30 cents, we're going to crank those things up and it's going to be more than 15 exahash. So the 15 exahash, though, is just kind of a number that when trying to sound like apples to apples so that people understand, but it's all over the place because, these chips have a lot of range variability.
Okay. And then you guys are working with Epic Blockchain on some of the other parts as well, which is another reunion for you guys since you've worked with them in the past.
We worked in the past, nice and close, Canadian company. And so it was, their office is actually not far from our office in Toronto, our Block office.
Better.
And, they've been doing this for a while. So it was kind of, they built the block miner, the Intel-based block miner initially. And so, there's a lot of expertise there. Our thing is, at Block is, what can we learn from who? And how can we accelerate? We want to be as open as possible. And if there's something that we know collaboration will help speed it up and make a better product, we're all for it.
Awesome. Okay. So then you guys are going to work with these two teams, Epic and Block, or Proto, I should say, to build the entire form factor across various facilities. And this 15 exahash could look at a lot of different ways across facilities, right? Once it's finally deployed.
No, it's fully open. Our lab space is their lab space.
Yeah.
All of our institutional knowledge is theirs to take advantage of. We have amazing conversations and say things that we've never been able to tell the secrets of this that we've learned. And
trust this guy, huh?
Yeah, they get everything. Well, he do a lot of them are rare, but it is it's the first, I think, significant collaboration between two really big groups that understand it.
Yeah.
And what it ends up looking like, we'll iterate too. And so I think that we'll certainly be proud of our first design, but we'll be even more proud of our second.
It's done a lot of timing, but we're in the middle of a lot of transition right now at Core with one of our sites are becoming HPC. And the interesting thing that does is that allows us to really iterate on our BTC mining as well, because we have some sites, we have some legacy sites, some older sites that we're going to have to take a lot of transformation upgrade for BTC mining. But if we're making those sites HPC, which we've announced that we are, it allows us to then take some of our newer designs and iterate in a positive way on our BTC mining. So just so happens some timing worked out pretty well. Yeah, and that we're in a growth phase, but this growth phase allows us to take and make some decisions from both the design perspective and, by the way, power agreement perspectives, to say, hey, these power agreements that worked well for us, BTC mining earlier, they might have more exposure in nat gas than we want. Yeah. So they maybe not, with that nat gas exposure, they're maybe not good for BTC mining now. With that nat gas exposure also means you get a firm PPA pretty easy because they're nat gas. A firm load PPA works really great for AI. So at Core, we're making a lot of decisions around our HPC expansion and around where we're going to do our Bitcoin mining, based on the fact that we also have this opportunity to come in and say, okay, we can now iterate our BTC mining design along with the machine design, the chip, and make decisions with all those things in mind, without necessarily costing us, because if we're replacing some of that legacy stuff with HPC anyway, then it means you're going to have your KDE too.
Yep. So one thing Larry touched on is there's going to be multiple iterations, and sometimes what isn't done at the ASIC level then has to be done at the hardware level. It's never as good as doing it. If you can do something at lower level, it's always better. Yeah, about that on hardware, then you have to make it up with software. So we know there's already things at NRX, the ASIC chip, that there's going to be learnings from this and that will be applied there. Something like, they want an extreme range between low and high, how it can cool. So that dictates the package size, right? If you don't, package size is inaccurate, maybe then you fix that with a heatsink or you throttle the machine with software. There's all these different things where the lower in the chain you can do it, the better it is overall. Yeah. And I think there's going to be learnings that are going to apply. I'm pretty excited, definitely for, I'm already talking about the next chip. Yeah. But, there's we don't see it as like this chip and that's it. It's a multi-generation approach, which is why when we're talking about, miner design, we're talking about, compatibility between generations.
So any timelines we can talk about for first reveal from Core for a unit?
I think we told everybody we're going to be turning these things on sometime in 25. I did in the first chips, like now, I think, and we're going to be sometime in 25. I mean, that's a moving target for us. But it goes back to what I just said. We do have a lot going on the HPC side. We're in all of these. I don't mean we're discounting the BTC mining at all. I just mean that we're trying to make the decisions based on what sites are going to be exactly engineered specifically for these things. But I think you're going to see us try to get as many of these things, deployed in 25 as possible.
Awesome. Okay, last question for you, for the block side. Will you guys ever sell these chips independently to just the market and people can make bid axes or whatever with these things?
Absolutely. The goal is, even if we give you the chips and we give you all this documentation, Larry will be the first. It's still not that easy. Yeah. There's in terms of bid axe, you can ask Scott what it takes to, even manufacture, even if someone gives you all the plans and everything else and the files, it's still not that easy. So we start with, it's a journey for us. Yeah. And it's a journey for Core. And we figured, okay, so this is how we're going to do a custom device with them. Now, if we ever want to do it where we'll happily sell you chips, but we don't want to just sell you chips that you can't do anything with. Yeah, it's complicated. The mining development kit was kind of phase one of that. There will be others. I wouldn't be surprised if we saw, a BidAx version with our chip at some point. So yeah, we want, like I always keep saying, we want it to be in as many hands as possible and many different applications as possible.
And by the way, one of our options, Chip, is just tell them to put them in their own machine. Like they're actually working on their own design. Yeah. Like we have some ideas that we like, but Larry and his team might look over and say, "Oh shit, I like that design." They're just going to take the chips and put them in there. It's a lot of what we like is flexibility. We like optionality. Having the option and having variability, it is very important to us, especially, we're in a very volatile market. Yeah. On the BTC side, the AI side has some extreme growth going on right now. So having that optionality, it's valuable to us.
And from the collaboration, they're going to build something great. And we had to be a part of that. And with other manufacturers that, food goods we bought, sometimes we don't even know what's coming in the shipment. It's whatever they've sent us. Yeah. And in this case, we know exactly what we're getting. And, we can say, hey guys, we like it, with the heat sinks a little over here. We like when the power is spread out of it. And all of that is being taken into account. And so, optionality is certainly there. But also, we want them to do great with this because, more supply chain, more routes, more ways for us to get, equipment on our shelves.
And it's not, their design, our design. It's the ideas merge, they collaborate. Theirs will be what they're building for their, specific site. Ours will be what's better for, let's say, there'll be some features that may not be there because they may not be required. Yeah, the average person or whoever is buying these machines of ours. But it doesn't mean, we still want to make it as cost effective as possible. But there might be some things that we see, this would be good, that would still work for them. And so it's not an either or, it's combine and what worked for them, what worked for us, and put the best product out there.
Awesome. Anything else to close out with? Any final thoughts from you guys?
I'll be really interested to see if U.S. government and others follow through with a Bitcoin reserve, what it does to the price of Bitcoin, how fast us and other miners are able to respond. So how long hash price.
Yeah.
Bitcoin has to go pretty parabolic for hash price to get high for a while. But
yeah,
I've been doing this a long time. We've been doing this a while. We've seen several cycles. It's fun when hash price is really up there. If people make bad decisions, we make bad decisions. People make bad decisions when margins are measured in the hundreds of percent. But I'll be very interested to see how Bitcoin mining in general responds at this point, because people aren't turning off, say, your 34 joule machines, your S19s, models from Bitmain. They're all sitting on the sideline. They're not being crushed or anything like that, right? They're not being recycled. And so what that means is we start seeing hash price go up. I'm very interested to see, especially with AI trying to take so much power off the market, especially in the United States. I'm interested to see what that does to Bitcoin mining. I'm interested to see how fast Bitcoin mining infrastructure can be deployed around the rest of the globe to make up for that. Just to see, how fast how long hash price, if it does go parabolic, how long it's going to stay out of whack before it drops back down again. We've seen that most miners can operate in the 4 to 5 cent range, but below that, people really start turning off. You start getting sweaty in the 6 or 7 cent range. Everybody's like, okay, we're kind of happy. You start getting above that, people start being comfortable and breathing in. If we get back up to 20 cents again, there'll be some irrational exuberance. There'll be some bad decision take. So I'm very interested to see if those bad decisions lead people to say, we're going to AI and Bitcoin mine on the same chip and the same power contracts, because that's kind of bad decision based on a hash price going up for 20 cents or 30 cents for like 4 days. You can make some really bad decisions that are like 12 and 15-year decisions. So I'm very interested to see, what that looks like in 25 and 26 as both AI and what could end up being AI and Bitcoin mining, chase some of the same power. I think it's going to push Bitcoin mining because of the flexibility. I think it's going to push Bitcoin mining out of the lower 48 and even out of Canada to some extent, and push it into other environments where Bitcoin mining can thrive.
Yeah.
But you'll have supply chain issues because like right now in states, if you want to go to a substation, it's like 3 years out. Not because it takes 3 years to go to a substation, it takes a few months, but there's certain supply pieces that really have long-term lead time. And the AI demand chasing that infrastructure is going to put pressure on new Bitcoin mining infrastructure in a very big way, especially at I just told you, from the substations, the electrical medium voltage distribution, it's the same shit. So if it's the same stuff, like there's going to be some pressure, and that pressure is going to be globally because AI demand is global. Like it's the big techs, the things are all chasing like here in the United States. But that same demand is happening in Europe, it's happening in MENA, it's happening in Southeast Asia, around Malaysia, starting in Singapore and all that. So I'll be interested to see how all that demand unfolds and how that supply chain happens. If it was a few months ago and hash price was going to sit at 5 or 6 cents, I could tell you how it was going to be. I knew exactly how it's going to be. Hash price goes up because we get a bunch of countries that do a Bitcoin reserve. Can't tell you what it's going to look like. Bitcoin, when it's running and hash price is running, the infrastructure pays for itself very, very fast.
Yeah.
So I'll be interested in the decisions people make.
I think people have learned from previous bull runs that it's a lot more expensive to buy equipment once hash price is pumping. So one of the reasons hash price is so depressed is we've seen so much hash rate come online, even with the price appreciating, the hash price itself is still pretty low. And so it's like,
it's not very high at all.
People are preparing in advance as something that really hasn't happened before because they have confidence that this is going to happen and they don't want to be caught flat-footed and having to buy a machine that was $2,500 at $10,000. 3 months later.
Okay. Thank you all for joining the Mining Pod. Appreciate your time.